Alright, I got the mic up. Gregory, let me see what's going on there. Oh, my nose is running today. Can you guys hear me okay? My allergies are killing me today. Oh, you're up there a ways, up by Altoona, so that's probably going to be where a lot of the ugly is happening right now. So you are right here by Huntington, and in the next 2 hours these storms will be right there, probably in the next hour. Looks like the small cells are starting to puff up more, and 3 to 4 o'clock is what we call magic hour. That's when the most fuel is available for storms, so typically that is when they start turning severe. So that's a tough call, but I wouldn't want to be out on the lake today with a possible microburst, downburst component, and even a tornado possibility in that general area. I can turn that on and show you exactly. Let's see, let's go to the data overlay and the outlooks for severe weather. Day 1 tornado. So that's down here, but not that far off. And lately, the past couple weeks, there's been a ton of tornadoes through the Altoona to Pittsburgh section. Every couple days it seems like. But the damaging wind threat is much more widespread. You can see that's the whole region, basically, west of the bay. So you're in it for damaging winds, and that means a microbursting, gusts to 60 miles an hour. So that's a tough call, but I would not want to be caught in a small lake in a big storm. That's for sure. Meanwhile, out west, they've already got tornadoes kicking off. And they've added Sunday. Remember I said on my Outlook heat was coming by Sunday? Well, they've already posted a heat advisory for Philly, the Philly Metro, and North Newcastle County, Delaware, New Jersey, Camden, Gloucester, Northwestern, Burlington counties, Pennsylvania, Delaware, and Philadelphia counties from 11 a.m. to 8 p.m. Thursday. So high temperatures, high humidity are going to mix there. And as I was telling you guys before, it's a basin. That sea level river runs all the way up through Philly. You know, and they've got the big shipyards and stuff all the way up past Philly into the bend. And that helps create a basin or bathtub-like condition all the way up through there, where the hills and the valleys kind of help hold the heat in. Same thing happens down at the Potomac River. We get those hottest temperatures of the year are always along the southern end of the Potomac River, south of DC, where it's sea level all the way up to Foggy Bottom neighborhood of DC. It's crazy. It's all tidal basin all the way up into almost to Georgetown. And with that, it's a big sea level basin that holds humidity and heat. And you end up with a really stagnant air, higher humidity, higher dew points, all in that region. And that's probably what supercharges these tornadoes. And that flash flooding, like Eater of Worlds has said, is also going on in that area. So I probably wouldn't chance it today. Out in the Midwest, they're going to get hammered the next couple days, it looks like. So if you're into storm chasing, it's already kicking off out there. 2 tornado warnings Way up by Laramie. That's crazy. So, and just for reference on my radar, this is what a basic tornado couplet looks like. I use customized colors to help find our tornadoes easier because our tornadoes are so much weaker. They don't show up so well on standard colors when it comes to velocity radar. So I've come up with these different color than what everybody else uses as a way to be able to detect a little better. And they do show up a lot better that way. It's been proven so far, so you can see a lot of times it won't show up at all. But as you can see here, this is a decent rotation scattered, but you've got the oranges here and the brighter blues. We put it in motion and it becomes more obvious. Broad rotation there. And then we can go here and take a look at the speeds. Whoops, clicking too many things at once. There we go. So 50 to 50 is not a super strong tornado, but that's a 100-mile wind, probably 100-mile-an-hour wind. That could be EF0, EF1. So that's what I'm working with here. That's customized. That's why it looks like that. The high-res standard storm velocity that takes into account the rotation of the storm is standard colors. And you can see same tornado, same couplet, and that helps it stand out because this radar is the same velocity type radar, but it calculates out the motion of the storm, the forward speed. Yeah, Gregory, I wouldn't want to fool around with a tropical downpour either. I was caught in what is the name of that? I can't think of the name of it. Totally blanking out. Oh, Bush River down here in Harford County on the Chesapeake Bay in the 90s. I was probably 18 or 19, and a buddy of mine got a ski boat, and now there's a good couplet there. Look at that. See that right there? That is a tornado couplet that is pretty stout. If we see anything like this in our area, then it's time to panic. But I got caught in a waterspout / tornado in the 90s on Bush River in a ski boat, and all we had was a canvas cover to snap down over top of us. I'll show you the difference between the two radars here. So this is the standard coloring. This is my coloring. It just kind of helps it stand out a little better for most people because the greens tend to blend into the rain and the, background colors. So that is what a standard tornado couplet looks like, and a decently strong one at that. So that would probably be a EF1, EF2 type couplet in our area, and would be pretty concerning because the whole storm is definitely rotating quite strongly. Our storms are generally base speeds, the lowest colors, dullest colors, with a little bit of a connection between the two, and that's about all we ever get. But so let's go back to Maryland here. Get off the dual screen setup. But Colorado Springs has a tornado coming at them. That's not good. It's not moving fast though. I think it was only moving about 20 miles an hour on the radar. It looked like it was slow. 15, yeah. So it could take it 2 hours to get there. And if you were watching the feeds yesterday, all the chasers were on one tornado that sat still in a field for 30 to 45 minutes and just drilled into the ground. It was crazy. And then it kept going and coming and going and coming and going. It was pretty wild. So here we have, when the velocity, no velocity at all, we have slow moving storms with hardly any wind gusts. But if a wind gust does kick up here, a bright color will appear and it'll stand out as a gust. So we can keep looking for, it's a little easier to tell here on my coloring again. So if something kicks off, I can send out a warning, because we get microbursts that can shoot out in any direction from the storm. The end of the storm here is kind of broadly, very slowly rotating. That's why we've got reds and blues with the grays. I'll put it in motion and you can see what I'm talking about. Well, let me back out. It's a little better to tell from up here. You can see it swirling. And that's what we're worried about. Basically, what's going on here is, as these storms ride along the mountains, I call them ridge riders. See that swirling action? It's because they're grinding against those 3,000-4,000 foot tall peaks. On one side, it's like a gear interacting with the land. It helps spin that storm that's already trying to spin. And we can get some tornado warnings kicked up off of that. Not necessarily a tornado on the ground, or a big damaging tornado, which is very rare, but enough rotation like this one is showing. If it tightens up any further than what it was right there, it probably would have set off a tornado warning already. So that's what we're looking for today. It happens more in this area due to the fact that it's hotter, warmer air and flatter land in the Pittsburgh region, and then it runs into very steep mountains, which you can see right on the map here. You can see these dark lines. These are the ridge lines, the mountain peaks of the Appalachians and Allegheny Mountains. So in the valleys, when the storms ride up along the valleys instead of crossing the mountaintops, is when you get bigger chances for tornado in this area in our little world. But yeah, the chances are always there for a small tornado to form this way off of these types of interactions. But more or less, this isn't any different than a normal summer day in our region so far. I had a feeling that this was going to split and the action would be more to our north and more to our south. There's not a lot going on in Southern Virginia yet either, but they do have some isolated supercells that are not. Get closer with the radar here. And these guys need to be watched because they're rotating already as they move. And as we know, south of Richmond is where we're at here. South of Charlottesville to Richmond is where the tornado activity usually happens when they come out of the mountains. And occasionally we get them back in the Charlestown area of West Virginia. There's a spot here where these storms tend to flare up over and over with tornado action in the Charleston area. So I would call this a mini tornado zone. Because we see them all the time through here. Big chimney down even into Lynchburg sometimes, but so that is definitely an area that's constantly seeing that. Excuse me, my allergies. Oh boy, it's gonna be one of those days. Another area that sees tornadoes often, but mini tornadoes, nothing special or outrageous. I like to call the La Plata area, and that's Culpeper. Well, really the Shenandoah Valley. I should back this over a little more. Really, it's like this area right here. As the storms come out of the mountains and they run into this hot, humid, flat air, that's always a good thing for a storm to find when it comes out of the mountains and it's been facing all that turbulence. My voice is messed up from allergies, so I'm having a hard time talking, but I'm trying to get it working. But this is basically the area where we see tornado spin-ups in the Shenandoah National Park. We had one recently in Luray, just north of Luray, and then down along 81. And I think we'll see something going on here today, probably. And then the La Plata freak tornado that wiped out La Plata, Maryland, that came across the Fredericksburg region. That was part of this group. So it's just one of them areas that causes that. We have another one in northern Maryland, north central Maryland, where in the Hagerstown, there's a couple little areas here while we're waiting for stuff to happen. Typically like South Mountain, Catoctin Mountain, as it comes off of the mountain right here, you can see it. That last ridge line of the Appalachian Mountains is right here. And if you've ever driven from Baltimore out to Hagerstown or out west further into the mountains, that's that first hill. You go way up and down. And from Baltimore, Fells Point, you're at sea level. And in 60 miles up Route 70 from Baltimore downtown to Frederick downtown, it's from 0 feet above sea level to the peak of that Route 70 hill, where you're at the very top of that mountain, is like 1,800 feet above sea level. And then you drop back down to around 500 feet in the valley floor where Hagerstown is. And that causes a lot of issues. What's going on here? So nothing's happening so far, but we're keeping an eye on it. Let's choose the local radar. Let me clear my throat for a few minutes, take a break. Just waiting to see what's going on here. We've got some cells popping up now. They're starting to get stout. This cell here along 81, on the east side of 81, is starting to get what looked like a hail core going on for a second there. Let's check it. Well, not really. It's kind of. Sorry about that. I got some weird noise. I'm trying to find out what it is. Bill Ryan, can you hear the music? I haven't been talking, that's why there's no volume. Been having problems with my voice due to allergies, so I've just been typing in the chat. But I'll talk for a few minutes here. There's not much going on right now anyway. So just for review, we've got a couple storms. I wanted to show you this while we're looking at it. What's going on exactly here. The main frontal system is kind of like this. And it's moving along to the east slowly. And then you've got these storms riding along it, and some of these storms are moving more north than they are east, and that's where you can get that twist. So in the mountains especially, whenever you have the storms riding along the mountain ridges, and you can see this is an actual picture map from satellites. I've got, a new warning there. And that alarm is a warning. I've got to see here. 1 second for me. Let me turn this music back down here. I'm sure it's echoey. There, that should help. Alright, so what we've got going on here is these storms are moving in across the mountains, but they're not doing very well, as you can see. They kind of drying up as they get to the Washington, D.C., Baltimore area. And if I move the radar up here, because the mountains cause a gap, this is the Sterling/Baltimore radar. Can't see past the mountains very well. If we change it to the Pittsburgh radar, we can see much more detail on the storms that are on the center down to the western side. And there's a lot of small cells out there, and some have lightning, some don't, but they pretty much all have heavy rain, and they're moving northeast more than east. So as the whole system is kind of like this, but at the same time you've got the storms moving at a northeast angle because they're being dragged to east and they're being dragged north at the same time along it. And that's where you get that spin. It's more likely to happen with storms in the mountains and spin up a small tornado because they're driving along those ridge lines and dragging like a gear against it. So if we turn to the velocity radar, you can see it a little better. The velocity radar tells us which direction the winds are blowing and how fast they're moving. Reds are moving away, blues are moving towards the radar. So knowing that the radar site is in Pittsburgh up here, we put this in motion, and you can see blue is coming towards the radar, and then as it passes that, it's moving away. The faster that wind speed is, the brighter the color. So if you get something moving backwards, it'll be blue on this side. If it's moving backwards towards the radar, it'll be, from the rest of the clouds, it'll be red on this side. And if it's a tornado, it's spinning. Therefore, you see spots where you get that action, and like this one right here. And that's a rotating storm. It becomes very obvious on the radar. See that? When they rotate, it's usually because they're making hail, and they're pulling that hail up in over and over and over due to an updraft. So they're sucking up that hot air off the ground, and they're making those big billowing clouds that you see on top grow. And that's hail inside going up and down over and over and refreezing. When that dumps out, it can displace a lot of air. Like if you've ever dumped the water out of a bucket onto dirty, dry ground, and you see that dust fly everywhere. Same thing happens in a microburst or a downburst. That storm dumps that water out of it, heavy downpours, and it gets it spinning. So everything wants to spin, but when it gets into the mountains, and you can see these mountains are, some of these mountains are pretty tall. This is the ridge line here from Morgantown up into Pennsylvania. And when they run up against these in the same basic direction, or they're, you know, close enough today, they can drag along that will help them rotate. And then the updrafts, because this, you got to remember that the land here is 500, 600 feet above sea level, suddenly rises 2,000, 3,000 or more feet above sea level. Bam. That's an updraft, and that squeezes and condenses the air, and that also helps the storm rotate. So there's a whole lot of interactions going on here, and that's why we're worried that we may see some spin-ups of tornadoes. But mainly, I think it's going to be just thunderstorms today for most of us up here in PA. That orographic lift where it's running into the mountains and it's getting squeezed out as it rises up over the mountains. Just like with Hurricane Helene down in western North Carolina, same thing happened. But a storm hits that mountain ridge and it has to rise up over top of it. And when you rise, air condenses and that squeezes the water out. You get extra rainfall that way. Heavy, heavy rains. And that's what's been happening out here in western part of Maryland, West Virginia, and PA. As for Southern Virginia, it's a different story. Let me flip this one here to the basic overall radar and put that in motion. So we've got these small storms coming through the mountains, and they're bubbling up in the heat, but they're moving very slow compared to the ones up in Pennsylvania especially. You know, 10, 15, 20 miles an hour, they're not getting anywhere fast. And as they move, they're dumping heavy rain, but they're kind of keeping the spin out of it and having trouble with the maintaining their rainfall rates. So they're kind of raining themselves out before they get anywhere. But that can change in the next hour or two. If the climate changes anywhere, it's going to be Southern Virginia. But I think they really overplayed this. Some of the local stations, especially, like we were just talking about with Jordan, really, really overhyped this. We haven't had any serious weather in a while, so that's what happens when you get these dry spells without major severe weather. They tend not to pay attention to the serious flooding that's been going on, and they only care about the stuff that gets the hits on their internet pages, which is tornadoes and damaging winds. So anytime there's a 2% risk, which is a ridiculously low amount of risk, it's basically one step above absolutely nothing being possible, which is never the case. You're going to see people online hype that 2% probability as a sure thing. But we've had more days the past 2 months without any risk at all being provided in the mornings, and then ended up with a couple of tornado warnings and even tornadoes those days. So there's just a game going on right now with the social media world, and it's not doing well for people that are everyday people. That's why I provide this page, to try to level it out and give you a place to go with just straight, honest truth, not hype and, you know, by the numbers, not really what's possible at the extreme end, but what's likely according to historical data and statistics, which is where it always ends up. Being a former ballistic scientist, that the law of averages is what rules the planet, and that is exactly what is likely to happen when it comes to weather, more often than not. But people want to play on those extremes to get those likes and follows and make that money easier on social media. But it's having a horrible effect on people's psyche. and social media has caused a massive upswing in people with storm anxiety because you're seeing it more, so it feels like it's happening more, but it's just due to the extra exposure. It's actually not happening anymore. Statistically, the numbers are the same as they were in the 50s. We have upswings and downswings, and everything is pretty much the same as it always has been. So you're going to have certain years where there are outbreaks, certain years where there are dry spells, and that's just how the data works. But when you average it all together, it doesn't end up looking any different than it normally is. So there's nothing to be afraid of with it. The fear that's being pushed out there is coming from people wanting to make money and greed, not from any kind of data or science fact, that's for sure. So Southern Virginia right now, Kentucky, Southern West Virginia, a couple cells scattered around everywhere. Nothing really going on there. We've got all kinds of, we used to call this popcorn storms. They pop up around 3 o'clock, 4 o'clock, which is magic hour when the storms reach their most potential. So if they're not firing off in massive numbers and quantities and turning super severe yet, they probably aren't going to. We may see this continue for another 3 or 4 hours, but at the rate it's at, it should be kicking off big time right now, and it's not. So they're actually drying up as they approach the DC area and coming out of the mountains. So for once, the climate in the mountains is more conducive to storms than the Piedmont Plateau, which is from the edge of the mountains right here over to the bay. Answer anything you want to know. We've got heat advisories for Thursday coming in. I said something this morning about the heat on its way, and it looks like we might be in the upper 90s by Sunday for a couple days at least. So our first big heat wave, not counting the one that we had back in April, that was odd. That's on the way for this weekend, and we're in the middle of a transition right now with the overall weather pattern. We're finally getting out of the springtime monsoon low pressure system after low pressure system. And if I turn that on, wrong button. Let's turn the fronts on and see what's happening here. So what's powering this is a low pressure system out to our west. And that's what's got this kinked up here. So there's a big low out here on the ocean, and there's one kind of right here over Virginia Beach, and then another one up here by the Great Lakes. And we've been having these over and over again, where we get these low pressures sitting out here, and then one down here, and then we get stuck in the middle. Well, this one's moved out far enough now to where this one has taken over, and it's actually up further now. I think it's actually probably about right here. So what happens is a low pressure rotates just like a tropical storm or a hurricane. It's the same thing, it's just lower power. Right, and it's rotating because all the air is trying to rush in to fill that low pressure, and it rotates in as it gets down to a spiral. Just like when you pull that plug on the bathroom tub, your bathtub in your bathroom, I mean, and that goes around faster and faster and faster into the center, and as it spins up, the faster that air rushes down in there, you get those bands of storms. Well, when it's a weaker pressure, you get these big spiral arms that move slowly across the country and countryside. And then it starts to turn the closer you get to the low. The angle starts to change. But what else happens with this type of system is, and I'll change the color here, as this front is moving this way, your storms tend to pump from south to north because the hot wants to even out the cold also. So you've got two different actions happening at the same time. And that's why you end up with the storms moving off to the northeast, because this whole thing is moving, the whole frontal boundary, or squall line, as you want to call it in the old days, and the storms pump north along that. The more intense this is, the nastier those storms are. Today, it's not that bad. The difference between the temperatures and the conditions at the ground level in front of this frontal boundary and behind it is the driving force in how bad the storms can be. So it's just a basic weather lesson. This time of year, as the temperatures get real warm and that colder air gets pulled down from Canada behind this, is when we can see those really strong frontal boundaries, squall lines set up in the afternoon when it's hottest. The difference between the ocean and the mountains and this hot air between it over top of us along the cities tends to create this repeated engine for storms over and over again, like we're seeing today, but stronger. We get those isolated cells that spin up. But we also get from this action on a much grander scale this time of year. We can get derechos. And we're in prime derecho season now. The middle of June to the middle of July is typically when we get the worst of the derechos. So the same thing that I just showed you is what causes those. But it's a big low pressure out here on a grander scale, or even a high pressure that can cause that. And what happens is the warm, humid, and literally stagnant air of the Iowa, Kansas, South Dakota cornfields, Minnesota cornfields, Kansas, all those flyover states where it's just nothing but millions and millions of acres of farm, generate a hot spot out in the middle of the country that causes the tornadoes in the spring. And we're getting those out there now, big time. But it starts to change to derechos, and then they fire off. So all that heat needs to escape to where it's cooler, and it usually ends up shooting off in this direction. Every couple days we get another one generated. Sometimes they hit South Carolina, North Carolina. Sometimes they'll shoot straight across the Great Lakes or into PA. And back in June 2012, we had one zing right across the mountains into Baltimore and across the beaches with 90 to 100 mile an hour winds. So they're rare, but they do happen this time of year. And that's something to keep in the back of your mind with your preparation kits, because if one does hit this area, like on Easter Eve where we had that mini one, that miniature one drove a 30-mile wide band of storms all the way from the corner of Pennsylvania here to the Delaware corner. 240 some miles, I think it was. Losing my voice again. It started that Easter Eve mini derecho. That's how far it went. Right about there. So it was like just over or just under the limit required to make, I think it's 250 miles it must travel to be qualified as a derecho. And that one just missed the mark or just made the mark and they didn't count it. But so this frontal boundary is stalled out right here, and this is why we're seeing these storms die as they get over to DC and flare up as they get up into the area where the line is parked. If we put this in motion, you'll see they start flaring up around here. They get their strongest right around that marker, and then they start dying off as they get over towards DC, where it's more stable air. So all this boundary layer marks out here is where there is a boundary where the two layers of atmosphere, one above each other, are interacting, and they're two separate independent layers that are interacting in a way that causes convection in storms. If you pull the photograph up, it would make more sense. It'll actually look close to this. So I'm really starting to think that we're probably not going to see anything today too wicked, but as I said this morning, there'd be a couple rounds, and the first round looked promising, but as soon as it got to this edge here, just like this storm is, rained itself out. As soon as it got to the mountains here. This last mountain plays a huge role in our weather. Let's show you some things while we're waiting, see if anything happens. So we've got 0 feet above sea level here at the bay. In downtown Baltimore, Fells Point area, you're 0 to maybe 10 feet above sea level. If you get on 70 and drive out to Frederick, you're going 50, 60 miles, but you're driving uphill the whole way. And Frederick is like 450 feet above sea level. And if you look closely, right after Frederick, you've got that big mountain that you can see in the distance as you're driving out there. You keep seeing glimpses of it. That's this mountain right here. High Knob, Round Hill are the peaks on South Mountain, Gambrel State Park. And then you've got up here Miller Hill, the Frederick City watershed area, which is basically just the forest on the side of the mountains and all the drainage. And then on the other side, you're going downhill and you cross another little peak, and then you find yourself in Hagerstown in the valley floor. And it's a beautiful drive, and you can see these. Here's South Mountain right here, big black rock, and you can zoom in pretty close with this. It's pretty crazy. You could probably see people standing here if you wanted. So South Mountain causes a lot of weather, but it's really this Catoctin Mountain that causes a lot of issues as the storms go from west to east in the hot summer days. We'll see them flare up as they cross this border of the mountain. So it's usually either playing a role of a fence, keeping the rain and snow in the wintertime out, or keeping it in if it's a coastal storm and causing us big amounts of rain. But that's 1,800 to 2,000 foot in height above sea level from here to 0. And that's a huge factor in the Baltimore, Washington, D.C., Frederick, and Hagerstown area weather, and why we have so many problems with models being wrong and people getting the forecast wrong, because it takes a lot of experience and a lot of data to understand how these interactions work. And with every change of overall wind direction, you get a different Completely different interaction. So, I wonder if we have a sea breeze set up yet. Let's take a look at the radar. Excuse me. As a sea breeze works, the air is probably too stagnant today because we still have these up, dense fog advisories up until 10 p.m., which means the onshore wind flow has welled up enough cold water at the beaches to cause that interaction. And we can look at the beaches and see how foggy it is right now.
Greetings, humans. My name is Daltron, here to tell my story about once a time upon.
First things first, this is not my voice you hear. I am transmitting via robotic sounds to your ear.
You may have heard of an AI song, might even think they're so wrong.
But what if the human and the machine combine? That's how Daltron was created, freed from my mind.
But this is the real me, not written by ChatGPT. No mentions of a vast tapestry. Found a therapeutic way to reflect and do some self-expression.
I'm trying to find the source of that. What in the hell? Where is that coming from? Found it. Apparently something opened itself on my computer and was playing in the background, or I must have bumped something. That was odd. I could not figure out where that was coming from, but it was some ad on a website, so apologies. That was weird. It's so hard to keep your computers running clean and safe nowadays. Alright, just 1 second. I'm trying to fix it and clear my throat at the same time, so give me 1 second. Uh-oh, what did you do? Jordan, did you do something? He's an alright guy, he just likes to copy all my stuff. It gets on my nerves. Every time I post something original, it appears on his page about an hour afterwards, reworded with AI. So, and then Tony Pan and the rest copy that, because they all copy each other. Storm Chasers are really bad for that, but it's gotten bad with the TV guys as well. But he likes to push his website, and you have to go there and pay him to see the things that I give out for free. So I guess it's an even trade. I don't know. Yeah, there is some fog in Ocean City, so that's what this is about here. They extended the fog warning, the dense fog advisories, until 10 p.m. tonight. And mainly that's due to the cold water. And a lot of times, the wind angle is what causes that, especially in the summer. Let's pull up the Windy app. This is something I normally keep open anyway. The Windy app is a pretty good app for details. Let me turn that down a little more. You'll probably hear that in the background. I need to just put my headphones in. But the Windy app, there's a paid version, which is what I have. It does a lot more, but even the basic version is good for different weather because you can choose the models. You can go and look at all the different models and it'll average them out for you, so it gives kind of a better idea of what's happening. Wrong one. So feel free to ask any questions. If you want to learn anything, if there's things you want to know about upcoming week, we can pull it all up while we're waiting for storms to not happen. Because apparently that's what it looks like. No, seriously now, the storms are probably going to be later in the day, as I originally thought. The models changed their mind this morning, but apparently the weather did not. think I'm back. I keep coughing out of my brain. But I think I've got most of the music straightened out. I turned it up just a hair so we don't get too bored. Alright, so yeah, basically what's happening here is nothing still. And like I said this morning on the forecast, it would probably be all the action to the south in Virginia, southern Virginia, south of Charlottesville and Richmond, because that's where that line is, as you can see here. And I knew that would set up there earlier or later today. And then up around the Pittsburgh, eastern Pittsburgh area. We're getting some lightning strikes out in Garrett County from the small cells, Morgantown, West Virginia area. And my main worry is for flooding out here again, because this has been hit so hard with the flooding already. But most of it seems to be happening on the eastern Pittsburgh to Altoona area. And this is being caused by orographic lift, which is the act of the wind carrying the atmospheric rain and clouds and storms up over the mountains. And when that happens, that squeezes and condenses the air mass itself, which, like a sponge, squeezes out the moisture. So they're having some flooding up there, Blairsville, over the roadways. They have flash flood warnings. Evansburg, or Evansburg they call it, reports of water across the roadways with more heavy rain coming in. So these little green dots are reports of flooding, and we can click on each one and look at it with Radar Omega. Displaced manhole covers, yikes. That's got some power. That tickle in my throat's driving me crazy. Ever since we had the smoke in the area, which it's not here today, but when the heavy smoke was here, I had that tickle and I can't get rid of it now. I'm gonna take an allergy shot. I'll be right back. I'm not gonna die, I promise. Okay, maybe I might die, I don't know. if that keeps up. It's possible. Shoo-wee. Excuse me. Sent everything flying across the room when I coughed that last time. Incredible. So anyway, we're worried about flash flooding in Pennsylvania. All right. So the heat's returning Thursday. Heat illnesses from 11 to 8 p.m. Thursday already. I didn't think this was going to come until Sunday. But this is for the Philly, Wilmington, greater metro area, and northern Delaware, Newcastle County. That Delaware Valley will be the first to get the heat creeping in. But this will probably spread Sunday all down I-95 to Fredericksburg, Baltimore, DC. So I would expect Sunday to be pretty miserably hot, like we haven't seen in a while. And what was I doing? Oh yeah, I was pulling up the Windy app so I can show you future casting and all that good stuff. Since nothing else is going on, we'll talk about what's coming up. But if you have questions, just ask. I'm here to answer anything you need to know. But so far, we've been lucky. No storms. It's already after 5, so I would have expected to see storms by now in the 3 to 4 o'clock hour. Normally that's when we have those storms explode into a serious, severe weather threat. Today, there was a back and forth between the models on if we would see that early or late. And my question is, are we going to see it at all, honestly? No more coughing, please. The heat wave is just coming from summer. It's just that time of year. So high pressure is going to move in, and it's going to allow that to build and keep a cap, like a dome, little hat, if you would imagine, on that when the high pressure moves in. So I'm about to pull up the Windy app where I can show you all of that and how that's going to work next week. It's just going to be a couple days. I don't think we're going to be locked into a long-term, long-range type heat situation. It's just going to be here and there a couple days. This year, the atmosphere has been so volatile that I don't think we get anything for more than a couple of days. So this is current, and with the Windy Professional app, you can really get into a lot of different modes to tell what's going on with the area. For instance, let's pull up the thunderstorms that I show you guys on the during the day on the morning scan, or I'm sorry, morning report. This is where I get this from, and I can change different models, and we can change it to different time frames at the bottom here. But this shows the intensity of the storms expected and where they're going to be. The lines are barometric pressure gradients. So you see the 1010, that's millibars, 1012, 1014, 1016. We can put this in motion and play it like a movie. So from now moving forwards, this is what they expect now. See, nothing. It's just gonna fizzle out through the rest of the evening. So I don't think we're gonna be seeing the storms that were being hyped out by most other forecasters lately. We can also zoom in a little, change the parameters around. Go back to current time. So this is the best chance for thunderstorms, and then the scale on the thunderstorms is on the bottom right here. That doesn't get severe until a 10, and when starting into the pinks, the dark reds and pinks on the map is where we start to worry about serious storms. So the temperature map shows us the temperatures, and if I play this, so this is 8 o'clock tonight, you get your temperatures dropping down. Always colder over in the mountains around the Canyon Valley. That's always the coldest area. The warmest areas are always at the Potomac River and the Delaware River and along the water. Now here we are, 8 a.m., 10 a.m. tomorrow, 12 tomorrow. We're getting in the mid-80s. 4 o'clock is when we normally peak temperature-wise, and that's right here, 5 o'clock. So 80, 82, 88. And that was Wednesday. Now here comes Thursday, and I'll stop it. So now we're building up temperatures. The sun's up now at 7 a.m. Thursday, quickly rising temperatures. And at noon, here's noon, I paused it, we're already 88 degrees, 86 degrees. And in Philly, they're up around 88. And I can pull up I didn't mean to pull that up yet, but so here's Philadelphia, here's Wilmington, and the Delaware Valley. And pretty much everywhere is warm, but this will be the warmest area because of the way the ground traps the air, and the lower altitude of the ground due to the Delaware River itself creates a bowl, or they call it a basin, the lower Delaware Valley Basin. Same thing with the Potomac River. South of DC, they call it the lower Potomac River Basin, and that's always one of the hottest areas. You can see here 88s along the river, 86s and lower around there. Over here we get into the mountains and it starts getting cooler because of higher altitudes. So that's basically how that works. And then when you get the pressure involved, which is what's bringing this, you can see on the other side of the mountains, much, much cooler. On Thursday. So if you are west of Cumberland, really Berkeley Springs, anywhere west of Berkeley Springs is going to be much more comfortable than along the city, the I-95 area. And the cities do play a pretty good role in the heat during the day, but they're usually 2 to 3 degrees warmer, but it doesn't get warm everywhere because of the cities. This is a overall geological and meteorological system causing this. So let's look at the pressure. That's not it. I missed it. There it is. Alright. So barometric pressure plays a big role, obviously. However, as you can see, a big low pressure above us to the north in Canada by the Great Lakes. This is on Thursday. And the high pressure out over the warm Atlantic, where this water temperatures are in the 80s and 90s already. will be pumping that warm air up to us, and the mountains kind of act as a guardrail to help guide it to us. You can even see that on the overall picture here. The Appalachian Mountains run right here, and you can see these. I don't know if you can see these little white dots, but that's to indicate the airflow and direction when the overall current. And I can make that bigger, but it looks a little crazy and it gets too busy. So the reds and the browns, I should say, are the high pressure. The higher the pressure, the darker that gets. And we have a big high pressure ridge sitting out over the Bermuda area on Thursday. And then the low pressure sits up here, and that's where you get the interaction between the two. We're right in between the middle of them. That's going to pull that southern warm air off of the ocean right up to us. But it'll be dry because the low pressure is far enough away. That's causing our rain today to not give us a problem. And I'm just checking the radar intermittently as we so we can plant flags to see what's going on, but it's all the same. So now if you want to see what's going to happen where you're at, you name your town. I can pull you a complete 5-day forecast here. 1, 2, 3, 4, 5, 6. I don't go past 3. Anything past 3, 48, 72 hours is bunk. It's not going to happen. It changes too much. But as you can see here, you can look at not hour by hour, but 3-hour block. I can change it to 1 hour, but it doesn't show you much information that way. So here we have Thursday. It'll be 86, 89, 90 degrees by 2 p.m. and then we're going to get storms in the afternoon because of that. Anytime it gets past 85 degrees in our area and the humidity is high, we tend to get storms unless there's a very high pressure over our area. Then the system that causes all this moves off again. We get back down Friday into 83, 85 degree temps for high temps around 4 to 5 p.m. Saturday, it'll be clear and hot, 90 degrees again, and then Sunday is a cooker. Sunday is what I've been warning about. 96 degrees at 5 p.m. possible, and that's in downtown Baltimore. DC, probably a little hotter. Usually it's a little warmer in the DC to southern Maryland area. No, not really this time. And then up here in Philly, I think it's going to be the worst. Yeah, 94, 95, 96. So it's going to be focused on Baltimore Metro, the hot temperatures on Sunday. $90 on Sunday in Bel Air, Aberdeen, Harford County. Downtown Baltimore, 96, 5 p.m. on Sunday. Annapolis on Sunday will be cooler because it's closer to the water, only 87 degrees. The further away from the water you get in between the mountains and where it's higher altitude means lower temperature, the warmer it'll be. But Baltimore will be the hot spot. So if you're doing downtown Baltimore or anywhere around the city, Baltimore City, Saturday and Sunday it's going to be pretty hot. Not as quite as hot on DC Wednesday, and the Alexandria to Tyson's Corner type area. Reston and all might be a little warmer, 95. So it's going to be cranking. Anytime you get over 90 degrees, your body has trouble cooling itself, and it's taxing, as you know. So that's the overall weather pattern. Thursday, tomorrow, we might get severe weather. Tomorrow we're going to see storms in the afternoon, 86 degrees. 87, 86 degrees around Thursday afternoon, but the storms will be stronger. And we can pull up all kinds of good stuff here. We can do the satellite. You can see these storms as they're developing. Let's do a 6-hour. I hope that answered your question, Claire. If not, let me know. This is the last 6 hours. These storms have been moving through, but most of them have been raining themselves out. And it's still pretty cloudy all over central Maryland and Delmarva, so I have a feeling we're going to escape the worst of it. The worst has definitely been up here in the Altoona area. When you see those dark gray cells like that, with the lightning inside, that's definitely where your problems are going to be on the satellite feed. This is visual satellite. This is what it looks like from space right now over the area. But overall, not a bad day. Rain accumulation, this is estimated. So you can plant a flag where you're at. Say you live in Mount Airy. And here's your forecast for Mount Airy for the next 6 days, technically. And then you can change NAM or what the HRR thinks, or the HRDPS, which has been okay lately, but is new. And that's showing where the rain streaks are. It's kind of a computer guesstimate. So a lot of data available on the Windy app that you can't get anywhere else, especially when it comes to working the models in a way that makes sense to you. So I like to keep that in the corner with the satellite running. Just, it looks good and it shows us what's happening overall, so we don't get any surprises. Squeaky brakes outside. So overall, if you put this in the 12-hour, it's really good for seeing the big patterns to help you understand what's coming. And that's a 12-hour evolution of the storms. So that can kind of show you and help your brain understand it from a bigger perspective. Time lapses are extremely useful for shortening the scale of time so you can understand it. When it comes to weather, it's a very useful tool, which is why I like to run them on the cameras outside all the time. But more or less, just big fronts working its way east. You can see it form up right there. I also use this to be able to tell if we're going to be able to see aurora or not. You can even see the smoke from the big fires up here. Once the sun gets over it, just huge barrels of smoke flying everywhere. All up in here. There's big fires over here. We can even highlight those fires with this app. It's amazing what you can do with this app. think of where it's at. There it is. Active fires. So in our region, all those dots are big fires. South Carolina, I should say. And Florida have a huge amount of them going on right now. You can see the smoke coming off of them. Pretty wild. So let's get back to our region. Put this down. Put that up in the corner there. Let's see what's up with the camera. I have another radar program that I use as well. I don't use it unless I need it because it's very intensive on memory, but let me fix this camera up real quick. Find us a good spot. There's a good shot right on the Maryland, PA, or Maryland, Virginia border, West Virginia border of I-68. Raining pretty good out there, but nothing major. Just a rainstorm, not a storm. And then Ocean City there with the fog above that. And we still don't have much going on here. There's no severe warnings in the area. And we don't have any major rain events going on, really. It's just drying up as soon as it gets to the mountains. So, as I said this morning, it would be to the north of us in the eastern and southern Pittsburgh region, and that's where it's been. Now, here's my only worry so far is as the evening progresses. Whoops, wrong color. So this line here starting to extend into Maryland and will likely extend further down as it moves. The whole thing is moving to the east. So Harrisburg, Carlisle, Hanover, Chambersburg, the I-81 corridor there, can expect storms soon in the next hour or two. And this is starting to extend down. And I worry that once it gets into this Hagerstown, Frederick area, that it might flare up and start pulling more moisture up into this. Cannot breathe. But overall, these storms aren't bad. They're just rainstorms. I really don't see a tornado risk today. And we haven't so far, so I'm not that worried about it, honestly. So let's chalk another day up to internet hype. And as I said this morning, the flooding risk. That's the eraser. Oh, no eruption. actually used that button before. I was curious what it was. So flooding still in this area as these storms keep progressing. And then of course we have flooding already active in this area, really over here as well. That's what these warnings are. These are flash flood warnings, which means flash flooding is occurring. Expect it. If you are in a low-lying area that floods and you are in a flash flood warning, you need to move to higher ground because it's dangerous. It could be rolling down at, especially in the mountains. It's definitely dangerous, as we saw yesterday, the day before, with the extreme flooding that blew out that apartment building wall. And I was screaming about that online, posting about it, but nobody was listening, unfortunately. Same thing happened Wheeling, West Virginia the night before. The Triadelphia area got completely washed out, where this river runs through here. And the Valley Grove to Triadelphia was just wiped out. You can see how it's low-lying. It's all basically built right in this stream bed. Here's the Route 40 corridor through here. The main highway, it was fine. They built it up high. I don't know who that was, but you can zoom in really close on this. All this got flooded out severely, and the roads closed mostly, all the way down to the bridge. It's a big mess. So North Wheeling Historic District, this is a cool town. If you ever get a chance, you need to go there and check it out. I wouldn't mind living there, but it floods out too much. And the river right now is the Ohio River, by the way. Let's take a look at that. It's flooding out. Not flooding, but it's very, very high. So if we go over on the bottom right corner there, you can see on the map the road is all closed. I was just showing you. So all of this here was completely washed out the other night at 2 o'clock in the morning. 3 people were killed in their vehicle. It was horrible, but you've got the main, it's a valley, and you've got the main road built up on the top, and then down on the sides you can see lower in the is the Route 40 corridor area, and the stream runs along it. So it looks like everything's working good here, but when you get further into town, it's just destroyed. They're still trying to clean up. Here you can see the bridge on this camera. Look at that water. 10 times higher than normal. That's the Ohio River. That's Ohio on that side, and we're on the West Virginia side. Let me make it larger for you. So I think me going live early to make sure people had the ability to catch the storms as they were happening and find out what was going on has jinxed the storm people that like storms. Personally, I'm done with storms. I don't like storms. And it looks like what's happening here is what I was saying. So let's go to the Maryland traffic cams. And we're going to take a look out here around Hancock and look at these storms. Starting to rain heavy there in West Virginia again. There's a little cell. That bridge is right here. The bridge in the bottom right corner is this bridge right here. Yeah, we got some cells moving through. Let's take a look at the cameras in this area, the Frostburg, Cumberland, and Hancock area. We'll take a look at the traffic cams. Sounds like they're having an outbreak out there in the Midwest. No, only one tornado warning. That's good. So you can go on here, Maryland's traffic camera page, and you can choose it by the region, and it pulls up just pages and pages, 70 pages of cameras. Or you can choose it by route, which is easier to figure out in your brain. You just pick out I-68 at the bottom here, because that's the one that runs from West Virginia to Hagerstown, well, to Hancock. Here's the first camera at the line. Sometimes it works. There it goes. So it's wet, it has just rained, but it is not storming there currently. The next camera, so that on the map on the left here, the camera was right here, where I-68 crosses Maryland and PA. Maryland and West Virginia, I'm sorry. Sorry, I was checking my cameras outside to see who's out there. So, Blooming Rose Road, up on the tower, 68. That's right here, Blooming Rose. There's a big tower here. Can't remember exactly where it's at. I found it once before. Scanning. So it's looking northeast to see 68, so it's got to be down here. Down here on the mountain. So anyway, that's where that's looking, right through here. That bend right there is looking at Blooming Rose Road. Alright, next is exit 42 Friendsville Road. A little bit of rain going on there in the distance, but it's sunny and raining at the same time. On the map, that is right here, the next road up. A little bit of Friendsville and the exits you can see right here. And that's the radar going by. Next one is Morgantown, Old Morgantown Road. Not much going on there. And that's literally right up here. Kaiser's Ridge Tower. Ouch. Beautiful shot of Kaiser's Ridge, which should be over here. Grantsville. So this is 219, where 219 comes down and meets I-68, which is right here. So that bridge right here is this bridge right here. And then there's the State Road, Salt Dome. Ow, get off of me. And we're looking south-southeast at the road from the ridge, which is right here. That's the mountain. Hang on, I'll be right back. The low-hanging cloud there, the Savage Mountain Tower cam. Let's pull that up. So here's Savage Mountain. St. John Rock, Frostburg is on the backside of this shot. Whoops. So I-68 at the Savage Mountain Tower. And we're looking south. So we're looking down this way. And that tower is right over here. And what we're seeing, and we're looking south, right across the road, you can see those clouds, low-hanging clouds, are not that low-hanging because we're up a couple thousand feet in the sky. But you can see that cloud really low hanging there, really wicked looking. And this is where we're at. And we're approaching the, right over top of Cumberland is where this frontal boundary is parked. So Savage Mountain is very big, very tall, and it's very pronounced on the map. You can see it right here. And that tower that we're looking at is up here, looking down south. Well, let me pull that camera back where you can actually see it. And that cloud is moving along nicely. See that cloud up there in the left side there, upper left. And then I'll move the map. So this is South Mountain. You can see the ridge line on the map. 70 or 68 is crossing right there. And we are looking south, so we are above Route 70 or 68, sorry. And looking straight south at the roads here, at the peak of the ridgeline, which is right, very pronounced here. And that's the cloud that we're seeing hang down on the radar, is the back edge of this mess. Let's move to the next one. Midlothian, you can see down the hill pretty far. And it's just barely raining. And Midlothian is just down the hill. So these two cameras are not far apart. This is just south of Frostburg there. So I think this camera is looking down, what's it say here? North-northwest. So the camera is viewing north by northwest. So that would be north-northwest across Braddock Estates. So we're looking at the hill basically from just past the interchange up the mountain. In this stretch right here that turns off to the right, just it meanders just a little bit. So we're down here and we're looking up along through here. And that's the stretch coming down the mountain from the top of the ridge line down to the valley floor. The sun's already coming out in West Virginia on the other cam. So our next camera, 68 at 55, and that's the big bridges, and you can see some clouds in the distance there, low hanging. And that's down here in the valley floor. Right here. Over top of Winchester Road. It's a very tall bridge too. If you look on the camera there, you can see it. All this stuff down below. And we're just jumping from one mountaintop to the next, basically. Neat little area. I love that shopping center there, where Martin's is and all. Wouldn't mind living out there if Maryland was still affordable to live in. So nothing on that one. There's the big 911 tower at Cumberland. Is a good shot. And that's over here. Went too far. And that's got the front right over top of it, so you can see the river meandering around the edges of the mountains. And then you've got the little two train, the old bridge. And I think that's right up here. Yeah, right here. So I'm pretty good with the maps. I have no idea what that person's talking about in chat. Andrea Carey, are you a bot or are you real? Please respond in the chat. Because the longer I'm online during the day, the more bots I collect, it seems like. So that's a rotating thunderstorm down on the North Carolina, Virginia line. Martinsville, Virginia. You can see it's got a hook on it. Let's take a closer look. Rotating thunderstorm with a severe warning. Not very organized. It's more like a bubble in the atmosphere. It's very disorganized. It was a lot more organized, and then it's losing steam as it gets over towards the coast more. Yeah, it definitely had something going on there for a few, but that's about it. It's going to lose its severe thunderstorm warning quickly at that rate, unless it can regenerate. But the Martinsville area, Martinsville Speedway, NASCAR racing at its finest. Short track. God, I miss going there. We are still without serious storms across most of the region. 6 p.m. Still have not had a severe thunderstorm warning in our region. We have a tornado warning. Guess where? By Pittsburgh. Remember when I said east and south of Pittsburgh? Let's take a look at this tornado warning. This is not coming towards anywhere in the mid-Atlantic. This is very slow moving, and this is north of Pittsburgh. This is probably 100 miles from Maryland. Let's see, it is 84 miles north of the Maryland PA line. It is not going to be anywhere near anybody. Mahoning, New Bethlehem, up in the mountains. There's an interesting target. Look at that river. That's interesting. Almost touching. About to become an island. Anyhow, we have a rotating thunderstorm. This is a typical couplet for our area, so this is not going to be anywhere near the Baltimore area. You can relax on that. Yeah, we have a bot in chat. Andrea Carey is a bot. Somebody report her. Her account is stolen. So we have 2 tornado warnings in the country right now. Let's compare them. We have a real tornado warning in Kansas, and then golf ball size hail. And then we have a typical East Coast tornado that's barely coherent. So take a good look at this. And I'll take you to school on why our tornadoes are different than the tornadoes out there. Okay, here it comes, moving along. You see that couplet. Let me shorten this up, it's a little long. 14 frames. With my tornado detection equipment, you can tell a lot easier on these lighter tornadoes that it is spinning on the standard velocity radar. On the relative, see how that's just a basic green connected to a red, and it's the dull colors, which means it's slow. You can see this is, 20, 30 mile an hour EF0 tornado. Probably not doing anything on the ground, but we can check that. Go into correlation coefficient. And that'll tell us if debris is flying in the air. And it is not. We don't have any dropouts. This would go down to 0 If there was debris, there would be a big blue area. This is very slow moving tornado, 10 miles per hour, which is basically walking speed for a tornado. So unlikely to produce anything, especially damage, but it's possible it is putting something down, and we'll check social media later to see. Now, after looking at that on my radar, let's look at a real tornado in comparison out in Kansas, which we probably missed. Yep, I think we did. We missed it. That's alright, it'll be easy to find. It'll be in the tornado area, and it's going to have storm chasers all around it. Let's turn the radar on. Probably this guy right here. Already produced a tornado. There's a marker here. So, law enforcement saw a tornado on the ground. Tornado report in Harper. We've got Vince. We've got Storm Runner Media chasing. And who's that? Connor. Yep, Connor Croft chasing. They're punching the core right now. And you can see this area is much more pronounced. And I put this in excuse me, if I put this in motion, you'll see these winds are much more pronounced and much stronger. Now watch. So it comes along here, and I need to slow it down. It's too fast. Oh, my radar changed completely. They must have updated it. Slow that down. Yeah. And the winds around this tornado, or rotating supercell, are much faster out in Kansas here. So 60 mile an hour. And the couplets around here, we got negatives in the 20 mile an hour, 30 mile an hour range. And this is not producing the tornado at the moment, which is why they let it die down, but it probably was a few minutes ago, because it had a warning on it at the same time. So let's back the radar up even further, 30 frames back, and it will see it where it produced the tornado here. So either way, 60 some mile an hour winds. I think it was precautionary. I don't know what's going on with that. But that's not a very good tornado product, but very high winds. So, and you can see there's a tornado watch out here. In the Midwest. Now, I don't know why that wasn't showing up very well. They've got some straight line winds that are pretty crazy as well, right in Wichita. The 70, 75 mile an hour gust a little while ago in Sedgwick. They've been getting hammered. If you watch my night watch, they had a 94 mile an hour gust last night. I caught right in this area. So flash flooding, a bunch of chasers. He's got a good view of it. Look at that. Wow. Now that is a serious storm. Milan, Kansas. That is a nice shelf cloud right there. Beautiful. This is out in Kansas, folks. This is not in our area at all. So, thank God you don't get that here very often. Back to our area, we have one warning way down on the North Carolina and Virginia line, and it's shrinking away. There's nothing here. So we've got nothing going on. We got a tornado warning right in the Hancock area. So now we might start picking up business. This is the cell we were watching a little bit ago, right in the Hancock region. This camera is very close to that. Let's pull this camera. The minute I looked away, tornado warning pops up right on the line. So this is just a little bit of rotation. These are very slow. That'll be 68 and 70. It's raining hard there, but you can't see anything. Just rain. This is most likely not producing a tornado. It's a very slow, very broad, very weak rotation, but this is the same cloud that we saw a few minutes ago when the this is looking south in the wrong direction. On the cameras, yeah. On the cameras a few minutes ago, this is what we were just looking at, that low-hanging cloud. So let's go to... oh no, I need a map. Pittsburgh region. Roadway 70. What is that? Bedford County there. There's a dark cloud there. That's westbound in Washington. Mile marker 13. So that's probably close to that on Route 70. This is probably going to get canceled. It's tightening up a little bit. Hail, it's a radar indicated only. So when you get a tornado warning now, you want to pay attention to the wording at the very top. Tornado radar indicated, which means it's not been seen, it's not on the ground producing damage. It just means that there may be a tornado happening. And then the next thing you want to see is the speed at which it's coming at you. So if you scroll down, if you look here, east at 15 miles per hour, which means it's barely moving. It's not going anywhere fast. So this is north of Hancock, heading towards the Dot, Point View, Warfordsburg area. And it's moving at 15 miles per hour. It's really over in the state game lands, but it's actually right over top of Amaranth, Point View area. So if we do our (15 or 10 miles an hour), it's going to take 15 minutes just to get the Dot from one side of the road to the other. Cobalt, which is over here, another 25. It's going to take 25 minutes, so it's going to take it a half hour just to get that far, as far as the blue cone. So ridiculously slow travel. I'm gonna split screen it. No, let's not split screen it. Let's do this. Let's put it back on the standard reflectivity. And then what we're going to do is 3D scan this to see if it's actually got a low-hanging cloud. Take a look underneath. Ghosts in here. Yeah, I'm not seeing anything too concerning. Looking underneath. With the mountains the way it is, you're probably not going to see anything anyway. But it's got a couple of big tall spikes in that general region, so see, when you get your height, your tops up over 50,000 feet, these spikes are getting high. So nothing too concerning here so far. It probably will end up not having a continuation. And we'll take a look back at the velocity. It's got a pretty good couplet going, where it's in between the mountains there. So this could be producing a funnel cloud, low-hanging clouds, wall cloud that's sticking down real low, rotating clouds, but it's not a very high wind speed around the circulation. It's only around 40. So this is definitely a rotating storm, but a very weak one, moving very slow. So take it seriously always. But as you can see, a 40-mile-an-hour tornado is not a wicked tornado. That is a very slow. Which is basically what I said this morning we would see is probably very slow moving, very weak, if we do see anything at all. And they cycle up and down in strength, so it may get stronger as it moves along the mountains. It will get brighter and then disappear and then get tighter. It'll tighten up. Yeah, see, it's broadening out. So it'll broaden out, tighten up, broaden out, tighten up, as well as speed up and slow down, speed up and slow down. And it gets that puffing action, that up and down, because of the mountains and because of microbursting. So this could do damage on the valley floors just because of the wind rushing down, the downsloping effect on the backside, but you just can't, you can never know. So it's better safe than sorry with these type of things. You need to make sure you're in a safe place until this passes. And it's going to take quite a few minutes to pass because it's only going 10 to 15 miles per hour. So to get to dot cobalt, you're talking another 20 minutes. I'll report this in just a second here. on the camera right there, you are seeing live a tornado right here. Let me pull it up. I was just talking to the NWS. Let me put it on video. Uh-oh. Looks like they're going to pull it from us. Anyway, on the still shot, you can still see it. So we are looking south from the north, and these are traveling westbound. Now, you can see this thin pipe on this side here. This has been traveling slowly on the edge of the storm for at least 10 minutes now. So this is a very thin, very slow moving, very weak tornado. But it is down. It is definitely a tornado. And it is definitely moving along with the rain curtain on the edge. It's pretty crazy. It's very clear. So they're probably accessing it. And you can see the low hanging wall clouds and everything with it. But look at that. Very obvious, very clear tornado. Moving very slowly. Not really a threat, but it might be tearing stuff up on the ground level. So I guess I should call State College back and talk to them. So I couldn't get through to State College. I had to call Pittsburgh because apparently the State College, Pennsylvania National Weather Service doesn't have phones. As we see this tornado and wall cloud get closer, you can see this pipe. This has been moving. It started out way down here in the distance and has been steadily moving straight up along with the rest of this wall cloud. And let me move this down out of the way. So you've got these dark clouds in the distance, and I'll pull this later and time lapse it, but we've been watching this thin, straight, slow moving pipe coming down out of the cloud for probably 20 minutes now. And I've noticed some cars like pull over, I guess to take pictures or whatever, but it's definitely moving slowly up the side of the road, right exactly where this area is, just outside the tornado warning now. But they've advanced the tornado warning, and it should say observed since we're watching it live on TV or live on Livestream. So here's a typical Maryland, Pennsylvania, Mid-Atlantic, Delaware tornado. Weak, slow moving, but it is there. It does appear to be getting a little larger and a little thicker. And it's coming towards the camera still, so we will see this in a minute. Let me keep it running. As it gets closer and closer. It's a shame that that watermark is right in the way. But the main black clouds are over top, so you can see on this side here, there's like no wind in the trees, hardly at all. So this is more or less just like a land spout. So I'm not even that worried about damage. It's basically just inflow into the storm as the storm got organized enough to be able to cause this, but there's no wind. It's just heavy raining more or less. I'm not that worried about it. And we're going to lose it anyway because the everything's going to get rain wrapped in a second. You're not going to be able to see anything. So you're not going to be able to see this if it does come, but and the camera's frozen. So that's probably the end of that. So we don't have anything else going on. There's 2 tornado warnings. They're both on this Fulton, PA area. And that's mainly due to the tornadoes being so slow moving. If it's doing anything, and now we'll see it probably past us already at this point, honestly. Anything worth viewing. Let's see if I can find a different camera view. Because this storm was pretty wicked on camera as it moved in. We might be able to get a better view from this end of town. Oh yeah, you can really see the very dark, very black clouds now. So this is looking from the Maryland state line north up into the clouds. And it's over the mountain, so you can't really see much. but it's already passed this area. And it's really fallen apart. There's really not much anything happening there. But for a few minutes there we caught it, and I'll have to go pull that back in a little bit. I might be able to do it now actually, but well, there's nothing else happening. But take it seriously, it could be causing damage if you're in these areas underneath this warning. This is just on the Pennsylvania side of the border, moving very slowly. I think they've got it at 10-15 miles an hour right now, so I think 15 miles an hour is probably high expectations, probably closer to 10. But it's heading towards Kiefer Mountain, Sylvan, Yeehee Mill eventually. Right now, if it's anywhere still happening, it's probably just south of right in line with probably Plum Run and the roads are Thompson Road, Pigeon Cove Road, in that general area where Cobalt and Timber Ridge come into Plum Run is where it's heading, very, very slowly. Jesse Huff, did you see anything at all? Just black clouds hanging down or anything? Let me know. It's probably going to be a non-contact funnel cloud type deal, where it didn't actually connect with the ground, or if it did, it was just a slow-moving land spout type tornado, and it's too weak to do damage. Hopefully that's the case, because this is a very weak rotation. The biggest concern is not the tornado, but the flooding that this is going to cause. And that's my biggest worry here. Let's pull this back off. Like hardly no rain there at all now. Another bright couplet return, so it's, like I said, pulsing up and down. It'll spin up and down, and as it goes up and down in the mountains, it'll help flare it up, but that's still not very strong. But that is a much brighter return than we've had. So probably 30-40 miles an hour. Yeah, that's about the coloring. 30 to 40, 45. So not a powerful by any means tornado, but that is enough to break large branches out of trees and knock them onto your structure. This is not coming towards Baltimore County at all. It's only moving 10 or 15 miles an hour, and it's a fluke, like a land spout basically, more or less. This is not really as much a tornado as it is like a giant land spout or well-organized dust devil, up into the clouds. It's only moving at 10 miles an hour, 15 miles an hour forward speed. So it's not getting anywhere anytime soon. It would probably take, even if it was heading towards Baltimore, which it's not, it's moving along the Maryland-PA border, it would probably take it hours to get anywhere of consequence. Besides right where it's at now. So let's do the math. So it's up here. Here's Baltimore. Even if it was to make a right turn and get there at its fastest speed, it would take 318 minutes just to get to Cockeysville. So that's a long time. That's 5.5 hours away at that speed. It's not coming anywhere. And these storms are not really severe, like I was saying this morning. They're just rotating. They have the ability to rotate due to the mountains and the directions that they're moving. And that's what's causing this storm, which is barely even putting out lightning. It's just a heavy rain. If you've ever dumped out a heavy bucket of water onto dry dirt, and that dirt splashes out in every direction, but it puffs up and rolls like a cloud of dust from the displacement of the air. That's the same thing that's happening here. As the storm dumps huge amounts of flooding rain into the area, it's displacing that air at the same time. And the air that's being displaced must be replaced up in the storm as the hail and the rain fall out so quickly, and an updraft sets up to fill that void back in because it's an exchange. And that's all a tornado engine is really, is as the hail and the heavy rains pour out of the storm, the air is displaced with it, and more air has to rush back in to fill the void, fill the vacuum. And you get that structure in an organized manner, and you get a supercell thunderstorm that's causing the tornado. So you should feel proud, folks. You've got the only tornado warning in the country in Fulton, PA right now along Route 70, but there are a dozen chasers out there spending big bucks chasing these tornadoes on much bigger, nastier storms right now at the moment. So taking a look out there, it looks like they don't have much going on. Overall, the whole day has been a wash for everybody, it looks like. But there's still the evening to go, so these storms are taking their time, but they are getting closer to Hagerstown. They're in the Hancock area to McConnelsburg, Mercersburg, PA area, slowly moving to the northeast and north. Well, actually, they're more west, moving more east now. They've changed direction again, and that's happening because of this front. See, this front has moved to the east further, as I said it would, as we were watching. And that's what's bringing the possibility of tornadoes always happen around that area. So it's still rotating. And as I said, it would go up in strength, down in strength, and it would pulsate over 20 to 40 minutes at a time. It would spin up, tighten up, become more organized, rain itself out, choke itself off with colder air from the rain it put out, and then fall flat on its face for a while, and then start reorganizing as it draws that air back in, and the mountains will help it as a mountain passes under it or the valley is below it, feeding it in nice warm humid air. It can reorganize again. So that's why we see them cycle up and down on like a 30 to 60 minute cycle, and they're moving slow like this especially. So now we're over by Plum Run, Dickey's Mountain, and it's starting to get reorganized. I doubt we can find it on the camera, but let me pull those cameras back up. The only cameras out here are 170 in Pennsylvania, but the Warfordsburg camera was showing it if you're just joining us. We had a decent view for a minute there. See, now it's nothing but heavy rain as the tail end of that storm. But still no wind. Normally we'd see these trees whipping back and forth, or at least whipping to the side if it was a wicked storm. But other than that, it looks pretty stout. Yeah, really far apart couplet. So that's a very broad rotation. As we wait for the scans to come in, let's pull up the good radar. Are the clouds hanging down pretty low? I'm sure they're very black looking. Try to pull up a couple different cameras, see if I can find anything at all. Yeah, there's some dark shots there, but I don't know where that is. Now it's tightening back up a little bit. Nothing really on the cameras. It's getting too far away. It could form a second circulation behind the first one here. We've seen that before where this main circulation is more hail right along Route 70. We're east of 70, north of the Maryland-PA border. Dickey's Mountain, Plum Run area, and it's moving about 10 or 15 miles an hour. It's not getting anywhere fast. So this is not a threat to anywhere else besides this general little area right here. So I know people freak out when they hear tornado warning, so this is a weak tornado and it is not moving fast at all. It is barely moved 5 miles in a half hour or more. So it's moving towards Mercersburg, south of Mercersburg, and eventually towards Greencastle, Hagerstown, more towards the Greencastle area. However, it would probably take it over an hour just to get to Greencastle. Let's see. It is about 18 miles from Greencastle. So at its current speed, if it keeps moving straight along the Maryland-PA border just to the north at 15 miles per hour, it will take it at least, let me move this down, $72 minutes just to get to Greencastle from where it's at now. At the speed it's moving. Very, very slow. But it's still showing rotation. Worley Town, 62 minutes. The nearest town is Warren, and that's a good 11 minutes away. I don't even see that one here. Shimpstown, Vanilla. It's all farmland for the most part. But here on this left side here is your possibility of the timeline before the tornado can arrive to Greensboro. To get to Waynesboro or Quincy, it'll take even longer. Waynesboro, 102 minutes out. So from Greencastle to Waynesboro is what, a 10-minute drive at most with traffic? But this tornado is moving so slow, it would take it an hour. So not a huge threat to everybody, but it is there. It is moving along slowly in this direction. And we did see it on camera for a few minutes on the I-70 corridor here on the cameras out of Warfordsburg, which I'm pulling up now. Oh, that's turnpike only. Negative third. Let's go back to that one camera. Washington, no. There are some wicked looking clouds out there, that's for sure. Just spinning out again. Not really seeing anything on these cameras either. So they've reduced the tornado warning. They've taken it, canceled it. And now we have a flash flood warning, which is much more important. This thing is dumping huge amounts of rain till 9:45. 1 to 2 inches are possible additional rain. This is just north of Hancock, folks, so we're talking about Cheneysville, Artemis, Needmore, the Big Cove Tannery, and it's moving towards Mercersburg really slow, really heavy rain, and it's rotating. It's going to look crazy. Could produce a tornado warning again. It was a very thin, very small tornado. And I'm not seeing much on the traffic cams that's concerning either. Looking around the rest of the state, I'll just take a quick look, make sure nothing else is going on. This is the only cell that's concerning at this point. I'm going to put it on the radar here. You can see how it's detached a little bit, and a slow moving supercell will do that when it's got a rotation. Usually it'll drag behind and make that comma shape. But it's kind of rotating still, but it's very broad. Very slow rotation. You can see how pronounced it was for a while there. couplet there, right on Dickey's Mountain. So as it's crossing the ridge lines here where these peaks, Cross Mountain, Kiefer Mountain, Dickey's Mountain, are happening, this thing is going to tighten up sometimes as it gets on the other side, especially as it rides down the backside of the mountain. That can help it spin up with downsloping effects. So Sylvan, Kiefer Mountain, Little Cove Road, Euclid Mill, Cross Mountain area, Shimpstown Road, up to maybe as far as Shimpstown itself and Corner Road, the Whitetail Resort. I'm going to pull the cameras on that real quick and see if we're getting anything there, because that's the next big camera that's going to have the ability to see what's coming. So I don't know if we'll see anything on these cameras. But we'll keep it running if it runs. They don't work all the time either, so. Yeah, this cell is pretty far away from Warfordsburg now, Jesse, so I don't think you're going to see anything anymore, as small as it is, and it's completely disorganized, but as you can see, it's probably closed. About 6 miles away with Dickey's Mountain, right about where it's at. So very slow and broad rotation, but it is there. And I was pulling up the other radar. Pull the power radar out, see what we got. It doesn't help that it's so far out. So here's the basic radar. I'll put the live scan on it. And we can do a little more with this radar. well, we could do a lot more. So here we have and this shows a good history because it includes the tornado warnings with it. So let's put the next rad on. Get that loaded up. And this is the cell, 10 miles an hour now, that's what I thought. Put the base velocity on there. You can see our couplet is about right here. Had a tornado warning and then it went away. So it was tornado warned and then it was gone. Currently no tornado warning on that cell. Still 10 miles per hour. Very slow. Let's see what we have with downdraft gusts. Gate to gate, whoops. Gate to gate shear. Still a good bit going on there. So it's still rotating, but just not that well. I need to load these up. So more or less, very weak, but it is there. You'll see the reds and the blues here interact as it rotates around. There was when it had the warning still. And this radar goes back with the warnings in the history, not just with. And that when we saw that, it was back over here by this highway. And that's when it showed the brightest gate-to-gate shear return right through there. So it was definitely something going on there. As for storm relative velocity, on this you can really see the difference. Nice and bright, obvious couplet. It's still loading, so I'll give it a minute to get caught up. Jennifer, probably not. It's definitely still rotating, but I don't think it actually produced any damage. And it definitely seems to be falling apart, coming back together, falling apart. But even at its peak, it was a very weak, very, very slow rotation. And it's only moving at 10 miles per hour, so I'm not sure where you're at, but if you tell me the town you're at, I can give you an estimate of if and where it's going to come through there or not. But it doesn't look like it's going to be able to do much. It's moving so slow. The flash flooding is the biggest problem. So it had a tornado warning. It canceled it pretty quickly on the second one here. Around 7 o'clock they let it go. So 10 minutes later and it's still not showing any signs of reforming, or enough to worry about at least. So let's go back to the other radar. Just very broad circulation still. Okay, Monte Alto. Yeah, you're talking like quite some time. So even if this got a new tornado warning on it where it's at now, to get to Monte Alto at 10 miles per hour, which is just over running or walking speed humans have, 150 minutes to get there. So you're talking an hour, 120 minutes is 2 hours. So 2 hours and 30 minutes, 2.5 hours minimum before it would arrive. If it stays together that long. It's possible it could, however. As you can see on the radar, every new radar it updates, it looks different because it's still rotating. When this gets over to 81, if it's still rotating, we'll be able to tell a little better. But that's probably an hour and a half away. 48 minutes to Shimpstown, which is right there. Worleytown, 86 minutes. Johnstown, 93. 95 minutes to Mason-Dixon. 102 minutes to Greencastle, state line. And 81. So that's 103, 102 minutes just to get to 81 from where it's at now. Which just seems like nothing, but it is rotating. If there are any storm chasing, amateur storm chaser type people along this area where this tornado warning occurred, it's not too late. They've taken it down, but you could drive, if you're anywhere in the area, from Hancock over to Hagerstown, and then from Greencastle, Mercersburg, McConnellsburg, you're going to run into flash flooding on the back side of this, but it is just moving very slowly along the Maryland-PA border. It is only 4 miles, maybe 3.5, 4 miles inside Pennsylvania from the Maryland-PA border, and it's moving east southeast. So it's going to head more towards the Maryland-PA line if it was to stay together that long in between Greencastle and Hagerstown. But it's highly unlikely that it could stay together that long. And you're running out of daylight, so, at 10 miles per hour, it's not something that's going to sneak up on you and kill you by any means, even if it does get a tornado warning back. So it's going to take a while. It's a very slow moving storm. It's just about the Kiefer Mountain now, coming off of Kiefer Mountain, Cross Mountain area, heading towards Whitetail Resort. So if you're at the Whitetail Resort, if you work there, you know somebody that works there, give them a call and tell them it's coming. probably going to have a very low, funky cloud with it, and it may be rotating. It may even be putting out a funnel cloud or a tornado. It's about 6.5 miles away, moving very slowly towards Whitetail. Whitetail's resort's cameras are not situated very well for seeing anything but the Whitetail Resort, which is fine. We understand. But their cameras are not working very well right now. Anyway. But it's working. So if something shows up as a whitetail, we'll see it. But it's got quite a few minutes to get there. It's about in Sylvan now. So right on Little Cove Road over Sylvan, Fort Davis Road, Furnace Road, Sylvan area, right there in that valley. What is that, Sylvan Drive and Shimptown Road. And it keeps getting a decent couplet. It's not great, but what you're seeing here more or less is inflow this way. Where the storm is rotating. Feels like it's got a pop, like it's caught. So you can kind of make it out a little better. And that's kind of how it's working, more or less, for that radar scan. Now, you'll see it if I put 30 frames on. We've been watching it for a while now, and zoom out. It'll be quite obvious that it's a rotating storm, but it's rotating at such a slow speed, it doesn't make sense to your brain. But now you can see it with the time lapse over an hour. Stronger, weaker, stronger, weaker, stronger, weaker, coming and going as the frames, you know, but it is there for sure. It's obvious, it's slow, it's not super dangerous. It's a very weak bottom line tornado like we normally see around here, and this is what they look like most of the time. And that's the storm relative that takes out the motion of the storm itself. On my radar with my coloring, it's a little more obvious what's going on, but it flips, but you can see the motions right in there. You can really see it spinning. With my custom color palette there. And then it kind of flips back and forth and reverses for me, so I can tell if I'm really looking at what I'm looking at or not. And it becomes a little more obvious right through here. So, to further outline it. Looks like it's spreading out now. You can see there. And there. And now it's spreading out, or gusting out. See how it's getting real wide on the bottom backside. It's either getting rain wrapped, or it's gusting itself out and falling apart and collapsing. As it cycles up and down, it'll do that though, so it might tighten back up after this. In the next 20 minutes, the next couple of radar scans, it might get another little point and the brighter colors around it. It's weird how these really low power tornadoes work. And it was hard to understand at first, but you're always looking for the extremes after watching them out in the Midwest and the insane power they have out there. It's pretty obvious to find. It's a lot harder to find these tornadoes when they're low power and in the mountains around structures and whatnot. The other thing you look for is to help try to confirm if it's a damaging tornado or not is you put the correlation coefficient radar on. And then you look to see if there's a debris ball dropout type area where you'll get some trash blowing around in the air, but you'll have a bluish, yellowish, bright ball for a debris ball if it's a damaging tornado and throwing things in the sky. So just to simulate what that would look like, you do your velocity and see it's tightening back up again like I said it would. It's at the top of the mountain. As it goes down the backside of this mountain, it'll probably spin out. Are we to wait till yet? No. I think we're getting close though. If I can get their cameras to work. It's getting foggier, which is a sign the storm's coming because it's pushing that humidity up. So the bottom, the top left corner, let me make that bigger just in case. The tornado, storm, whatever you want to call this, is actually coming over the hill. I can't tell if the camera's dark on this side or if it's just a shadow, a weird bug or shadow or something, but anyway, this is looking at the hill, and this tornado has tightened up, and here's whitetail right here, so it's getting very close, and it's coming right at whitetail, right at this slope that we're looking at right here. I can zoom in on and watch this. There's the Express quad, and that's the Expert's Choice quad that we're looking at in the camera, which I think is right here. Yeah, that's it. So Expert's Choice quad, this is the hill that's in the camera, and that's right where the tornado is coming. So if there was a tornado, I should say rotation, not tornado, there is no tornado technically. We'll mark it. This is the Expert quad on the camera here, on the top left corner. The rotation probably right in here at this point on Trimstown Road. So it'll be a low hanging wall cloud type feature. If it shows up, it'll pop over this hill here. It looks like we are live. There's 2 other people watching, so somebody's paying attention, listening to me. One of them is probably the NWS to see what's happening. There's a new scan as the radar keeps scanning. So now we're in the clear air ahead of it, and that's part of the inflow notch. Let me back out a little, and it'll make more sense. So there's Whitetail Resort right there. That's Whitetail. That's the mountain ridge that we're looking at. The flat side. And we are looking right here. In that direction. And here's the rotation. Very broad. So there might be a couplet right in here. So it's headed right at this camera. It's been zipping along at about 10 miles an hour. So it'll come walking like a Bigfoot over top of that hill if there is one. If there's anything happening at all, which I kind of doubt at this point. But the sky will get real dark real quick because we're up at the edge of the clouds. So as long as this camera is running, we should see something. It's moving so slow, it's painful. The chances of catching it twice, I already caught it on camera once. To catch it twice would be near impossible. Hang on 1 second for me. I'm not seeing anything yet. Let me check the other camera. I don't think it's working. It is offline. The base area. That is live. I see the inside of that thing spinning. It's starting to look a little dark up in that area. I don't know if that's the camera or the clouds, but it's getting close. It's so slow. The whitetail's right here. And tornado forming part would be right here. There's the new scan. So a whole lot of nothing going on really. Just a big broad rotation. It's really broad now. So as it goes down the mountain, it's on the other side of this hill and it broadens out, and then as it comes up over the mountain it tightens up as it rises. It spins as it rises. real fuzzy on the right side of the camera there. Look at that. We're in the clouds. So that's the storm coming over the mountain right now on the camera. See how that's all fogging up all of a sudden at the very top. So we'll see that happen on both cams. It'll fog up at the top as that low hanging cloud moves across that peak. I'll keep it here, you can see the fog at that very top there. That's pretty cool. And the trees are starting to move around a little bit at the top there. If they start whipping, then we know we're in trouble. Literally right on top. Whitetail Resort now, where these cameras are located. Here's the resort. Change it to the other one. So the couplet would be right in here if anything was happening, but doesn't look like it. Trees are starting to whip around a little tiny bit. Pretty neat to see happen live. Now this is not going to reach anywhere, Jordan. It has only moved maybe it's going 10 miles an hour, so it would be probably 5 hours before it got to Towson. So we're just watching it out of interest because we saw it did have a tornado warning, and it is still rotating broadly. There's lightning. So we just saw lightning, and now look, here's our lightning hit right here. The plus sign. Now let's look at the other camera. Look at the fog filling in into the valley there. And that's because these are high up in the sky. But nothing violent happening. You can see the treetops are just barely moving around. And these are up in the clouds. So even though this is showing a tornado warning and it is showing a couplet, it's a good lesson for everybody to see what can really transpire, where it's got the rotation, but at the same time it's really just not doing anything. Right over top of Whitetail Resort right now. Trees are not whipping back and forth. You can barely tell if it's live or not. It's so still. If it wasn't for the fog rolling over top of the mountain itself. You know, it's trying to tighten back up though. Now we see the rain starting. The fog is thick up there now. You can barely see the other side of the hill, especially over here on the where the gondolas are. So it's interesting that there's not that much happening with this storm. Whitetail Resort right here. The storm's halfway past it. But all we're seeing is fog and some rain and a couple lightning strikes. You can really see the fog blowing and the rain blowing now on this cam. But not much to it. It'll probably get more windy and the trees will start moving a little more as the sun starts to get brighter. As that rear flank downdraft starts coming in the back, feeding up into the storm to help keep it going. But with this, it's not a strong one. It's not like out west where a rear flank downdraft is identifiable easily. Nope, this is the bottom of the scale when it comes to a storm. It's just barely there. So even though the radar looks crazy and looks evil and red and dark reds, and it's got the, the swirls in it and all that stuff, this is how weak a tornado can be and still count as a tornado warning until somebody reviews it and looks at it. And as we saw in the beginning, yes, it did technically create a tornado because we saw the white funnel live on the camera, but it didn't produce any damage. And the worst of this is from flooding rain, which is just now coming over the mountain. So here comes the thick, heavy rain, which appears as fog on the video most of the time. So that's the worst storm in the area right now. Horrible. Nothing really to worry about so far. And it's getting late. Almost 8 o'clock already, so. It's good that we caught that on camera though, so people can see exactly how tornadoes really work around here. Excuse me. Taking a look at the storm chasers out west in the Midwest. Look at what they're working with. They've got storms going in every direction, colliding with each other. It's just total madness out here with the way the storms are moving. I mean, it's wild. Incredible storm motions going on. If you click and look at their cams, the skies are a little meaner out there. This poor guy is stuck right in it. This guy bailed out. He said, "No, thank you." PG got a good shot there. So you can search these people on YouTube by going and just putting in live storm chaser at the top. And then the radar app here, Radar Omega, that I use, as well as some others, will link in their signals so that you can see them right on the map. It looks like she's headed right into it. And they've got a big green monster hail producer there. Look at that. Tornado Pagey. She's out there with the best of them. But look at that monster. Wow. That's a serious hail maker right there when it's that color. You know it's bad. When it turns green like that out here, people say that's a myth. It is not a myth. When the sky turns that deep teal green, it means that there is a big hail core over top of you, and it will get ugly. I think this thing is producing like baseball size hail. Yeah, huge. There's a view for you. Look at that. So that's from Pennsylvania looking south at the storm. There's South Mountain or Catoctin Mountain in the distance. And that's where Whitetail is also. So same rain that's hitting there and that downpour is the same rain that's hitting here on this camera. And you can see it's pretty heavy. There's a little bit of a hanging down cloud over here on the side, but go back to video. Pretty cool shot. So that is the storm that we're looking at on the radar live. It's the only storm in the area at the moment of any type of concern. It is dumping copious amounts of rain, and you can see that rain curtain moving east, which is left from this camera's point of view, but east is to the right on this camera. And it is approaching 81, which is what we're looking at, Route 81 here. We'll zoom in close. So that camera's right about here. We'll just watch that walk across there for a few. Jared, you're looking right there live at the camera. That's with the storm. This is 81, Hagerstown is to the south. We're in Pennsylvania looking down towards it. So that is the mountain right there in the distance, and on the other side of that mountain of Whitetail, that's all it's doing. Nothing to be nervous about at all. It's just rain with a couple of lightning bolts. And we're watching it move live. And on the screen here you can see here's Hagerstown. Here's the storm. Here's the 81 going into PA. And then here's the storm coming in. And that's all it is, just big rain curtain. There's no high winds, there's no warnings, there's no anything happening besides a few lightning bolts and a whole lot of pouring rain. It's actually pretty neat looking. I actually wish I was there with a high quality camera on that pole to get that shot. So we might see some droopy looking clouds hanging down, little fingers of clouds that stick down, and that's just, they call that scud clouds. But they're not rotating, they're not forming anything, that's just due to the interaction of the two different layers of the atmosphere that's causing the storm. If you're going here on the PA 511 PA website, if you find these cameras on the map, you have to keep clicking them every few minutes or every few seconds. Where it says hide video, it'll say show video suddenly, and everything stops moving, and you've got to restart it over and over and over. It's quite annoying, but it's the only way to see it. That's how fast a 10-mile-per-hour storm moves right there, though, on that camera. It's just now covering up the mountain. It's been moving so slow. We've been watching it for 2 hours.